Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
This episode of Coding 101 is brought to you by Casper, an online retailer of premium mattresses for a fraction of the price, because everyone deserves a great night's sleep. Get $50 off any mattress purchase by visiting casper.com/C101 and enter the promo code C101. And by DigitalOcean, simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code C101 in the billing section for a $10 credit. Today on Coding 101, Lou Maresca and I have killed Wally. Hello and welcome to Coding 101. It's the Twitch show where we let you into the wonderful world of the Code Monkey / Code Warrior. I'm Father Robert Ballecer, the digital Jesuit, and joining me is my ever-present co-host, Mr. Lou Maresca. Lou Maresca, now, this is a great day for many reasons. First, because we get to do some coding, and we both love ourselves some coding, but also because you have spawned a new process.
That's right. Yep. Number 3 boy for me today. So 1 day old. So we're living happy, and it's gonna be a great Christmas.
Can you name him Bobby Drop Tables? I mean, that would
I was gonna try Benjamin. I couldn't get my wife to agree on Benjamin Franklin, but his name is Benjamin.
Oh no, sorry. Okay, wait. We have to stop. Give us all the stats. So weight, name, do the whole thing.
7 pounds 6 ounces. Benjamin is his name, and 19.5 inches long. Healthy as an ox, ready to go.
So congratulations, Lou. Seriously,
Thanks.
from the bottom of my heart. But also, you are a crazy man for agreeing to do a show the day after your wife gives birth. I very much appreciate it.
No problem. Great to be here. It's always fun.
It is. Oh, and actually, it's nice to have you because we get to play a little bit with more Arduino tricks. We've really been sort of going whole hog on this. I have to say, there's been a big push in San Francisco by Make. They created a Make pop-up space in downtown San Francisco off of Sutter Street, and it's been going like gangbusters. People have realized that they want to get their young kids into making, and this, the Arduino or the Atmel chipset or variants thereof, have really become the cornerstone of the Maker enterprise because it combines software with hardware, and it is so affordable, easy to get into. In fact, this little project that I've got here, this little ring light, this Arduino, I think the total price on this, because this is a knockoff board, was something like $6. Have you been playing much with Arduino, Lou?
Yeah, absolutely. I've been Arduino. I've been doing a lot of the little newer devices that are coming out. So it's like the NeoPixel, I think, is another one.
Oh yeah.
So yeah, there's a whole bunch of them.
Yeah, and actually, can you go to the overhead, Jason, and drop the lights down a little bit? I want to show you some of the things that we played with last week. So this is our project from last week. This is just something I was messing around with. This is actually off of an old Leonardo that I had sitting around my makerspace. These are WS2812 LEDs, and like we said last week, they are individually addressed. So I have the ability to create an array and then push it down the string, and every light takes the bytes that are appropriate to it, that set the light and the brightness, and then it passes it down the line. So I have the ability with a single wire. So this is just power. So I've got two for that, of course. There's ground and there's the voltage. Yep. And then the digital line is one single line, and it allows me to do all these things. So this one is using a potentiometer to turn an analog setting into a digital setting that is then used to determine which lights light up and at what colors they light up. And this was all done in a relatively few lines of code because we use libraries. Now, Lou, we talked about libraries in Coding 101. I think this is probably the easiest way for our audience to really understand the value of using a library, because I can use very advanced functions without having to actually code them.
Yeah, and there's a great place. I mean, you go into GitHub or wherever, and you can search the libraries to figure out, like, if you want to do something very specific, especially for these S2812s or whatever. I think that's what they're called.
2812s.
2812s, yeah. So yeah, there's actually a couple libraries out there, in fact, to do You do special blinking and special, moving in a clock. There's all different types of libraries that different people have already built for you. So that makes it easy, kind of an easy bootstrap to a project.
Right. Now, I will say it's not as simple as just loading up libraries and you're done. You still have to understand how the libraries work, which is why I like an Arduino, because you can make it as difficult or as easy. In fact, many of my projects have started by using a third-party library, something I got off of GitHub. And then I say, you know what? This is good, but I want to make it better. I can make this library better. So I improve the library, and then I push it back up. That's kind of the heart of the open source movement. Is it not, Lou?
Yeah. You just describe what open source is all about, is making, improving things, adding new functionality, extending it, and then giving it back to the community. So yeah, definitely.
Yeah. So we wanted to do another Arduino project. We wanted to build on what we did last week, but also perhaps introduce a new wrinkle into play. And we came up with this. And no, it isn't Wall-E. It does look like we killed Wall-E, but this is actually something I came up last night because I realized that Lou, with his babies, probably wouldn't have time to create a C# project. This is an Arduino Uno combined with a WS2812 light, so the same ones that we used last week, so the same libraries that we used last week. But at the front, this is actually a SR04 ultrasonic sensor. The way that it works is it sends out an ultrasonic pulse, and then it receives it back. It receives the echo, and then it can compute with a library how far away an object is by looking at the delay between the pulse and the receiving of the pulse's echo. Now, this all sounds very simple, but I mean, putting it together can be complicated if you don't actually know that a lot of the work has been done for you. So what we're going to do on this episode is we're going to take you step by step through using two different libraries to create this device. Now, let me go ahead and lower the lights again. I want to show you really quick what this does. So this is, originally I designed this for my parents because they're always running into things in the garage. So I created an ultrasonic sensor that as I get closer, it actually starts giving them warning lights about how close they are. And I told them they want to stop right about when the lights get to yellow, right about there. And if they continue, it goes to red. And of course, red means no, seriously, no, mom, no, seriously, stop. And then actually, if they get all the way up to it, the lights just start flashing.
I need that thing.
Yeah.
I need it for my garage.
Super simple circuit. But I've also designed this because I was thinking I wanted something that maybe I could start using, a very low-cost sensor for using in quadcopters, a way to do some collision avoidance, very inexpensive collision avoidance. Now, let's look at the part breakdown. So if you are looking at doing this project, this is not going to be that expensive. This Arduino Uno, this is a knockoff. And I think we've got a link there, Jason, if you want to throw it up. You could find this on eBay. I think this was $361. It was free shipping. I bought like 10 of them. So I have a bunch of these sitting in my lab for when I want to whip out a quick customized processor. Yeah, there you go. So it's $361. It was free shipping. Don't buy one, buy 10. I mean, they are cheap enough that keep a bunch of these around because these Arduino Unos, what you want to do is you want to build something and then not have to disassemble it. I do keep a couple in breadboard format, but I mean, if you've built something and it's that cheap, why not hold on to it? You also need, and the next link, this is going to show you, this is the HC-SR04 ultrasonic sensor. It's 99 cents. Again, free shipping if you buy it on eBay. So I bought, oh, actually, it went up in price. Okay, so it's gone up from 99 cents to $1.32. Go ahead and get yourself a couple of these. It's, again, very useful sensors, but you just want a big box of them for when you actually want to do a project. The next piece, and we've got a link for this, is this. This is the Ready to Fly. This is a PixelStick. It's just a string of 8 WS2812 individually addressable LEDs. Now, I will say this. You can, and I have bought a bunch of cheaper ones. In fact, I bought, it's like a set of 30 PixelSticks. They look almost exactly like this, a slightly less quality, for about $1.25 on eBay. And I thought I was getting a deal. But of the 30 that I bought, 20 of them were crap. They didn't work right. They had dead LEDs or stuck colors. So I tend, on these kind of parts, I tend to order in the United States from a vendor I can trust. That's why I go back to Ready to Fly Quads. Those for about $3.25. So for less than $8 here, you're making yourself a very cool ultrasonic ranging detector. And then I just 3D printed myself a little holster for everything. I'll actually put the design for the holster on the webpage. So if you want, you can go ahead and 3D print your own. But these are not that hard to make. Lou, you ready for some coding?
Yeah, let's do it.
Let's do it. Okay, so the first thing we need to do is we need to get our assets. And I've actually made it very easy for you to get the assets. In the show notes for this show, if you go to twit.tv/code, you will find a link to get this. If you could go to my computer, Jason. This file, this zip file right here, C10196 ultrasonic ranging, that will be available for you to get. Now, let me go and delete this so I don't get an error. Oh, I didn't get that. Once you unzip that, what you're going to get are these. You're going to get some assets. 2 of those, so the fast LED master and the ultrasonic folder, those top 2, those are the libraries that you need. That's got all the pre-written functions that we're going to be using inside of our program, which is nice because it means you don't have to write it. And it's also got that 3rd folder, the ultrasonic ranging. That's the simple file, the sketch that I threw together that will actually give you the code to make this all work. And I have super commented the code, so you don't actually need the show notes. You just need the link. And if you read the file, it will tell you exactly what every line of code does for you. A quick note. For the folks who are wondering about what you do with the libraries, it's actually really simple. Go into the folder that has your Arduino installation installed, and there's a folder there called Libraries, like this. These are the libraries that it will come with a bunch of them. They're default for Arduino that you want to use in all of your sketches. All you have to do is select those 2 libraries that you downloaded, copy them over into your libraries folder, and now you have access to all those functions. If you don't do that, I'm sorry, Lou, go ahead.
No, I was going to say, we would talk about fast LED really quick, but keep going there.
Yeah, exactly. Yeah, if you don't do that, what you're going to do is when you compile your sketch, you're going to get an error. So yeah, don't do that. Oh, and by the way, the reason why I didn't put these on a GitHub is because I wanted to make it a nice tight package. The issue that we've had sometimes is that when we send people to GitHub, if the GitHub source has changed since we did the episode and it broke the function that we used, people get upset. So this is a self-contained way for you to get these libraries. Now, Lou, now that we've got these libraries, we've got this. If you go back to my screen, Jason, oh, wait, we have to unzoom that. There we go. So this is totally nothing. This is how it looks when we first open this up. What we need to do is we're first going to show you how to use the ultrasonic library. The ultrasonic library in order to make the ranging function work, because that's the input. We're going to deal with the input, then the processing, then the output. So let's start with the input. In the input here, the first thing I need to do is I need to include a file for my library. So include, and then my library that I just downloaded is called ultrasonic.h.
And that specific library will actually will link to all the other libraries that you have, correct?
Correct, right. So the way that libraries are structured is they should, inside of themselves, automatically refer to the libraries that it's dependent upon. Now, there are well-constructed libraries and there are poorly constructed libraries, but typically the poorly constructed libraries don't get shared, they don't get passed around. All right, now that I've got this up, what I have to do is I have to initialize my ultrasonic sensor. The way that I initialize this is I tell the Arduino where is it located. Oh, go back to the overhead shot, Jason. What we've got here, it's not going to show you really well, but you've got 4 pins on this. Now, the outer pins are going to be your ground and your voltage. So that provides 5-volt voltage to the ultrasonic sensors. That's what powers it. It allows it to do its job. I'm taking that power directly off of my Arduino. By the way, if you're worried about the hardware setup on this, don't, because we're actually going to do this as a know-how project. We're going to show you the hardware side. This is the software side. The 2 internal pins are my trigger pin and my echo pin. And those are important because what the trigger pin will do is it will tell the ultrasonic sensor to send a pulse. What the echo pin does is it gives a signal back to the Arduino when it receives an echo of that pulse. And so that's how ultrasonic works.
Feedback loop, yeah.
Yeah, it sends out a ping and then it bounces back. And then the library is doing all the math. It's saying, well, if I received the ping X milliseconds after I sent out the ping, and we know that sound travels at X speed, then I know that the object is X distance away from me. Actually, that's a lot of X. I probably should have changed those variables. I just overrode all my globals. Oh, forget about that. All right, let's go back to my coding screen. So I need to tell my Arduino where am I going to find the pins to address this SR04 ultrasonic sensor. So what I'm going to do is I'm going to go ultrasonic, And this is a function that is built into the library I just imported. And actually, most good libraries will include an example sheet. So it's like how to use this. Ultrasonic, 1312. What I have just told it is I've told it you're going to find the ultrasonic function inside the library, ultrasonic, and I want you to use digital pins 13 and 12 for the trigger and then the echo. So send out a pulse on 13 and then receive the signal back on 12.
That's just initializing the actual unit.
Exactly, and I could use any pin I want. So I've got all the digital pins on Uno or Leonardo or Mega or whatever Atmel chipset you're gonna use. As long as I tell it where it can find those digital pins, it will be able to use those digital pins.
Right.
Does that make sense? I mean, I'm hoping the audience is getting this so far. This shouldn't be all that difficult.
Well, it's just kind of your setup logic. So you're just initializing this unit, and then you're telling what pins are going to use, and now you're going to write your logic to actually access it.
Precisely. All right, now we go to the void setup. Now, remember, the setup inside of an Arduino sketch, this is sort of where you put all the, this is not the main program. This is where you put the things that have to be started up. In this particular case, if I don't open up a serial console, there will be no way for me to find out what the ultrasonic sensor is actually detecting. I want to be able to push something back to my serial device so that on my screen I'll be able to find out how close or far away that object is from the ultrasonic detector. So what I'm going to do is let's go ahead and open up a serial port. Serial.begin 9600. What I've just told it is open up a serial port and set it for 9600 baud, bits per second. Now, okay, Lou, you're old enough to remember hooking up like a serial modem, right?
Yeah, I'm just waiting to hear the tones in my ear, right?
Okay, this is a generational joke. All the people Gen X and before, we all remember the excitement of hearing it go because that means the internet was coming. That was woohoo. This is the same thing. If you don't set the right communication rate, you can have a communication mismatch. Your computer might be listening.
There it is.
Wait. Good recall. Very nice. Folks.
That's 14.4 though. That's not 9600.
Yeah. That's the true geek. The true geek who, no, that negotiated wrong. That actually fell back. That's 300 baud. That's horrible. No, but if you don't set the host and the client at the same communication speed, they won't talk to one another. You actually just get gibberish. All right. So I've opened up a serial port. I've set it for 9600 so I can communicate with it properly. That's the only thing I'm going to...
Real quick, apologize. So how did you know it was 9600? How did you know that that's the rate that you have to set it to?
I mean, that's because it's what I have my my serial monitor set for.
Got it.
Right. So, I mean, okay. if I was going to use a terminal and set it for, 11.5, I could do that too. It's just 9600 is... And also 9600 on a lot of these devices tends to be the default. So... that's one less thing to remember whenever I'm doing this on a new machine.
Got it.
Yeah. All right. That's all our setup. Now let's actually do the program. Now here's the wonderful part. I love this. Because we're using a library, we don't have to do the math. The math would have been trigger the sensor, receive the signal back from the echo. Now let's crunch the numbers. Speed travels at this sound. It did a round trip, so I know that it took X milliseconds, so divide that by 2 and divide that by the speed of sound, and that's the distance away from my device. I don't have to do that because that's all contained in the library. Instead, I'm just going to do this. Int, so I'm creating an integer. This is just a variable where I can store a value, range. And that tells me, okay, this is how far away it is. And then I'm going to call, I'm going to say that integer gets filled with a function call to the ultrasonic library called ranging. Ultrasonic, ranging. And then I'm going to say cm because I want the value in centimeters. All right. There we go. Now what I need to do is if I just ran this, all it would do is it would just keep running in a loop and I would never see anything. I just have to assume it's working. But because I've already opened up a serial port, let's go ahead and get that information out in some usable format. I'm going to put serial print line range. And what I've just told it is push the, see right here, push the variable range, which I just created by calling this function inside this library, push it out to the serial port, which I just created. By the way, this is driving me crazy, so let me space this properly. All right. So what I want to do with an Arduino, let's verify this first, because this will check my dependencies. This will make sure that everything's working properly. This will make sure that the code's not going to do anything malicious, like put it into an eternal loop that will never work. If I get this line at the bottom, it means, okay, yeah, it looks good. Now let's look at actually programming the Arduino. The hardware has to work like this. If you go to the overhead, what I'm going to do is I'm going to make sure first that I am hooked up to the right COM port. Yeah, this is COM 5, and I'm on using an Arduino Uno. There's a reset button right next to the USB port. I'm going to push that, and then on my sketch screen, I'm going to go ahead and hit upload. It's going to take a couple of seconds, and if you look down towards the bottom, it's done uploading. Okay, so now this has the new code that I just created. You'll notice that it's non-functional anymore. The lights are just lit up, because I just took away the part of the program that addresses the WS2812 lights. The only thing it's doing right now is triggering the ultrasonic sensor. So the question is, well, how do I know it's working? I know it's working because, and if you go back to my screen, if I open up a serial monitor.
Dumping it out.
There we go.
There
we go. See, so now I'm getting values. That's telling me in centimeters how far away the closest object is. So if I get here, I'm getting like really close, and basically, and if I do this, if you make contact, it screws it up, because now it's not echoing anymore, right? Because I've covered up the ports, but there we go. Now, one of the things that we do want to do is, this is hard to read. So Lou, you think, what easy function do you think we could use to sort of slow this down?
Sleep?
Yeah, or a delay, right. It's
delay,
actually,
right,
for you, it's called a sleep. For us, it's called a delay. So come back to my screen. What I'm going to do here is, at the bottom, I'm going to put a delay of 200. And that will make it wait between every loop, so that that screen doesn't become so unreadable. So again, I'm going to push my reset button, and then I'm going to upload my code. And boom. And done uploading, and it's going to restart. And now if I look at my serial monitor, it's much more reasonable. Now it's not just screaming past. Now you can set this delay for whatever you want. And the reason why you want to set a delay sometimes is because, especially when dealing with a sensor like an ultrasonic monitor, you don't want it peaking and going down whenever you get something like this. That would make it freak out. So you can say, okay, I don't care if you wait half a second, and then give me the reading, so that it's not continuously vacillating so much.
Right.
And that's
also depends like how fast the object's going to be too. So if you're pulling a car in at a specific speed, you want to make sure it grabs a bunch of data while you're pulling it in. Right.
Actually, that's the other side, which is you don't want to set the delay so high that the car only sets off the trigger after it's hit the trigger. That would be
that's right.
That would be a bad thing. All right, so that gives us the way to address the ultrasonic sensor. It's super, super simple. Again, all I've done, I've given it power, I've given it a trigger pin, I've given it an echo pin, and I've added a library and literally written like 5 lines of code. That's it. That gives me complete access to the ultrasonic sensor. Now the question becomes, what do I do with that information? How do I make that give me information in a useful way without having to connect to the device and have a serial console open? We're going to tell you exactly how we do that after these messages from the first sponsor of Coding 101. Now, let me ask you, if you are a developer, if you are a coder, then there's probably one thing in your life that you miss the most. Lou, can you guess what that is? Something that you want to do, but you almost never have time to do it.
Back stuff up.
Back stuff up. Oh, that's good, but I was thinking of sleep. I kind of threw.
Oh, that too, yeah.
It's according to the latest Gallup poll, most Americans spend 20 hours a day sleeping. That's not true, but we do spend a lot of time sleeping, and unfortunately, not enough of us think about the quality of that sleep. I mean, yeah, you may say you've gone to bed, but if you're constantly tossing and turning because your bed is lumpy or just uncomfortable, it's not quality sleep. And the strange thing is, even though we might spend thousands of dollars on a comfortable chair and hundreds of thousands of dollars in a comfortable theater, we balk when we spend more than a couple of bucks on a bed. Well, that's why I'm so happy to have Casper as a sponsor of Coding 101. Casper understands that quality sleep is probably one of the most important things that you'll do in your life. It's something you do every single day, and it affects your health. It affects your work. It affects your productivity. If you don't get good sleep, you will not be the person that you want to be, and that's across all sectors of your life, from your personality to your output. Now, Casper is an online retailer of premium mattresses for a fraction of the cost of what you would get in a retail store. They're revolutionizing the mattress industry by cutting the cost of dealing with resellers and showrooms, and then they pass their savings directly to you. Now, think about the way that you would normally choose a mattress. You'd go into a mattress store, right? And you don't really know what mattress stores are good. You just know the one that's close to your house. Now, maybe they've got a showroom with, if you're lucky, a couple of dozen different models. So you lie down on each one for 30 seconds, maybe a minute or two, and then you get up and you move to the next one. And then you have to make the decision about which one you want. Oh, and by the way, it better be the right one, because most of these mattress places aren't going to give you a return policy. Once you take it home, it's yours. Now, the way that Casper works is completely different, because they understand that you need to try your bed in the place where it's most comfortable. That means your home. That means your bedroom. So they will send the mattress to your house. You get to install it into your bedroom, and you actually get to try it. You get to sleep on it for 100 days. Within those 100 days, if you don't like it, if it's not the mattress for you, if it's not comfortable, if it doesn't give you better sleep, you send it back, and they give you a refund. Folks, that's the way that we should choose our mattresses, and that's why I, like Leo Laporte, love Casper. Now, here's what you can do. You can get a Casper mattress, $500 for a twin, $950 for a king size, at a price that's comparable to industry averages. And that's an outstanding price. Plus, you get to test it. I mean, how many of these mattress places are going to give you an offer of saying, take it home, if you don't like it, bring it back? And you can save an additional $50 as one of our audience members by going to casper.com/C101 and entering the promo code C101. That's casper.com/C101 and the promo code C101. Terms and conditions apply. For more details, visit casper.com/terms. Get a better night's sleep. Code your heart out with Casper. And we thank Casper for their support of Coding 101. Lou, what do you think so far? I mean, this is pretty easy stuff, right? I mean, we haven't done anything that should shake anyone from the lesson just yet.
Yeah, easy as pie so far.
Yeah. All right. So we've got our ultrasonic ranging feature set up. We know that it works. We know that it can detect how far away it is from an object. That deals with our inputs. That gives us the information we need for our program to work. But now we need a way to process that information. We need to turn that into something that's usable. So let's look at the actual logic. In this particular logic, and remember, this goes back to the original Arduino project that we did with Mark Smith, we know that we can get some value that determines how close something is to the ultrasonic sensor. In order for me to be able to do something with that, I have to take that value and then put it into some sort of logic tree, some sort of decision tree that says, if this close, then do this. If this close, then do this. If that close, then do X. There is one other thing, and Lou, I'd love to get your opinion on this. If you go back to my serial console, you'll notice that technically this thing could get out to maybe 200 centimeters. You really start to lose resolution as you get further and further away from the sensor. And see, like the 3331. 3331 basically just means the sensor doesn't know what's going on right now. It got confused. So what I need is I need to compress these values, and I need to average them out so that any singular mistake isn't going to throw off my logic tree. If you were doing this in C#, Lou, what would you do?
So I would take probably the 90th or the 85th percentile. So I wouldn't necessarily average, but I would take I'd kind of average out, get rid of the lower and the higher values. And so this way, like you said, kind of take the mid-range values. This way you're not getting these extremities out there.
Right. And actually, we do have a function that we can use, and we used it in the last lesson. We call it mapping. Let me see if I can bring this up from the last one. There it is. Int light map equals map range value 0 to 80 number of LEDs. Remember, we did this for the analog switch because we had the very same problem with the analog potentiometer. We wanted to take a range that was kind of wildly varying, and we wanted to map it to a range that was not wildly varying so that we could build our logic tree off of the range that was more constant. What this lets us do is it lets us set a low value and a high value for that ultrasonic sensor, and then map that to something that's going to happen. So in this particular case, again, I'm saying from 0 to 80, which is what I want to detect. I want to start detecting something when it's at 80 centimeters, and I want to stop detecting when it's at 0. I want to map it to the number of LEDs to 0. Now, people who watched last week's episode will notice that this actually differs from the code that you received last week, because we went from 0 to the number of LEDs. And that was because for that project, we wanted a 0 to equal 0 lights, and we wanted full to equal full lights. In our case, we want to do backwards. We want to do a reverse range. We want 0 to be what was it? I'm sorry. Yeah, we want it to go from dangerous to not dangerous. Does that make sense, Lou? Do we saw Lou? Oh, you're muted.
That makes sense.
Okay, yeah. Yeah, so in other words, when the thing is the furthest away, we want no LEDs, and when it gets closer and closer, we want full LEDs.
Right, and you have a limit to, like, so you don't want to necessarily go down to 0 because it probably won't register, right? So I think it's, like you said, 1 is it should be the minimal value.
Exactly. And actually, there are a couple of things here that our audience will be able to improve, and hopefully they'll improve it like we did last week. Last week, we got some great improvements using loops to fill our arrays instead of having to handcraft them. All right, let's go and look at the code that we've created for this new example. This is the fully commented code. This is what you will be receiving when you download the module. And again, I made sure that you understand exactly what every line does. As you can see, we've added another library. We had to add the fast LED library. This is the one that we had from last week. I will say this. You will notice when you add the fast LED library, your compile times will greatly increase. I mean, you go from 3 seconds to something like 30 seconds. The reason for that is the fast LED library is actually quite big. There's a lot of meat to it, and every time you compile your sketch, it goes through that library and grabs all the function that it needs. Now, just like last week, there are a couple of pieces that we have to include if we're going to be using the fast LED library. The first is this: define. We have to define the number of LEDs inside the WS2812 strip that we're using. In this particular case, it's a NeoPixel, and there's 8 LEDs. The reason why it needs to know that is because it needs to know how big of an array does it have to create to control that strip. The second piece is, just like we told the ultrasonic sensor that it was going to have echo and trigger and echo pins on data pin 13 and 12, we have to tell the Arduino what's the digital control pin for the WS2812 strip. In this particular case, it's data pin 7. This next piece, this is going to create an array that's as big as the number of LEDs you have. And the reason why it's creating that array is because you can fill that array with the color values you want for every single light. Remember, one of the nice things about WS2812 is that they are individually addressable. Well, the way that we individually address them is we fill the array, then we push the array down the strand, and that controls what each light does. All right, this is the initialization that we saw previously for the ultrasonic sensor that tells us to call the ultrasonic library, call the ultrasonic function, and tell it that it's got a trigger pin of 13 and an echo pin of 12. Now our setup has changed. You'll notice that not only are we opening up the serial console, and this is for debugging, because I still do want to be able to get those range values out, but I'm also telling this that I need to use the FastLED function, FastLED library, and then I'm telling it exactly where it can find the NeoPixel, the data pin, the LED array, and the number of LEDs. What do you think, Lou? Is that clear?
Basically, you're just initializing the variables again, just to making sure that the library is initialized to whatever it needs to be able to communicate to the LEDs. So it seems simple enough.
Yeah, exactly. All right, so let's go ahead and move down. I have a debug function in here as well, the range debug. Again, once you get this working, you could take that out if you don't want to have to worry about the compile time, but it's in there to make it a little easier whenever you can get it. Now let's talk about this. This is a function I created for ranging. This is going to create that light map. This is the light map that remaps the distances into the range of the ultrasonic sensor. And the first thing I'm going to do is I'm going to create this with that range value from 0 to 80, from full LEDs to no LEDs. I'm going to clear the WS2812 strand, And then I'm going to use much of the same logic that I did for the last project to determine what these LEDs are going to do. So the first two LEDs are going to be, as you can see here, the first quarter of my range, the LEDs are going to be blue. The second quarter of the range, my LEDs are going to be green. The third quarter of the range, my LEDs are going to be yellow. And the last quarter of my range, the LEDs are going to be red. And that, of course, says stop, stop, stop. Now, I will say this. I put CRGB and then I put the color there. I could put a hexadecimal value. If any of you have ever done web programming, you know you can do hexadecimal values to determine the colors. You could do that here too. You could fill the array just with hex values and it will push it out to the LEDs and they'll understand it just fine. The last step is I set my brightness and then this. Fast LED is a call to the Fast LED library, and it's a call to the function called show, which pushes the array down the strand. Okay. Now, Lou, what have we said about the main program loop in the past? How big should it be?
Fairly small, because you don't want to put too much on the stack all at once. You want to make it do just very simple things.
Exactly. Yeah, all right. And that's what we've done here. We've made it so that the actual program loop, what it does over and over again, there's as little in it as possible. It's just calling different functions. So let's look at what this does. This does that piece where it's calling to the function inside the ultrasonic library. It's saying, give me in centimeters how far away an object is from my ultrasonic sensor, and put that into the variable called range. Then it's going to call the function called range debug, and it's going to pass it the value of range. That's the range debug function is the one that pushes it out to the serial console so I can see how far away it is. And the last bit is it's going to call to the range LED. This is the part of the program that's actually pushing to the string of WS2812 lights and giving it how far away it is from an object. And then that function determines at that distance these lights should turn on. And then it delays 100. And if I, hold on, let me close off all my other Arduino sketches so I'm not messing up my COM port here. What I'm going to do is I'm going to go ahead and push this up, and I should get back to my original sketch. First of all, I need to
So just real quick, that delay function you're using too is in milliseconds, so it's pretty fast. 100 milliseconds is pretty fast.
Right, exactly. So what we're going to do is I'm going to push the reset button, and I'm going to upload. The first thing it's going to do is it's going to compile the sketch. It's going to make sure everything's okay. It's going through all the dependencies, the libraries, and hopefully, unless I really screwed something up, it should go through. Actually, I think I know what's happening. The other Arduino sketch did not release the COM port.
You're still running your loop over there, so it's getting confused.
There we go. Wait, and there. Now we should be back to the original. If you show the overhead here, again, as something gets closer, we get more and more LEDs further away, fewer LEDs. And if I look at the serial console here, do the split screen.
Very cool.
There we go. So as that number decreases, more and more LEDs will light, all the way up to here. So at about 5 and below, it's going to go the second red light, and that should tell them. Now I could do one more, and one more would be at 3,000 and above. I could just say you have had an accident.
Crashed.
You have just died. Yeah. There we go. And folks, that is an ultrasonic range. Now I should say, this is a great project to do with your kid over the weekend or just over a day, because this is nothing. This is literally 3 pieces of kit that's going to cost you $8, and we've given you all the code. Now you can trick this out. I mean, you can attach more and more WS2812 LEDs like this. This is a little ring LED that I've also used for larger projects. Even the large one that Smitty had with the 60 LEDs, or those Christmas ones that you see that have hundreds and hundreds of LEDs, you do it exactly the same. The only thing that you would change in this program is where it says number of LEDs. And that's why I designed the code this way. So that one value, number of LEDs, it could be 8, it could be 5,000. And as long as you're providing enough power to the string, the program will work the same. The first quarter will be when it's at a certain range, the second quarter, the third quarter, and finally, danger stop. So Lou, what do you think? What comments do you want to give to this? I want to get your expert eye on this, because again, this is something that we threw together last night. I want to see what a professional programmer thinks about killing Wall-E and ultrasonic rangefinder.
Well, one thing to note too is the fast LED library. It works with a bunch of different microcontrollers. So you could do, if you find out that maybe the Arduino Zero is a little bit more expensive than something you can find, like you were saying, some of the knockoffs. But there are some things like the Spark Cores, the RFduinos, or the Teensy LCs. Any of those are supported also by the fast LED. So, and of course, it also supports multiple different variants of the 2812s too. So that's why, you want to find the one that you found is actually a very versatile library that you can make easy changes to. So stick with the ones that have the most people contributing to, because those will make it a little bit easier and cheaper in the long run to kind of do some of these projects.
Right. And we've got Tricky W in the chat room who's saying, it's a fun project, but you shouldn't trust your life to this. Yeah, don't. This is a hobbyist project. So, of course, you do want to have less than life and death stakes attached to it. Now, we will do some final thoughts on this program and all future programs using the Arduino. But first, I do want to thank the second sponsor of this episode of Coding 101, and it's got to be DigitalOcean. Now, DigitalOcean has been with Coding 101 for a long, long time for one simple reason, and that is they're good for developers. Now, if you are a developer and you need to get your projects out into the real world, or you need to test them with a small deployment, there's really no better way to do it. Because the old way it made you create a server farm. You had to get the right hardware and the right connections, and you had to make sure the software was maintained. Well, that's the old way to do it. The new way to do it is to use droplets. DigitalOcean lets you make these virtual machines that can be deployed on a single core, multiple cores, multiple machines, or across the world. Scaling your project up and down is as simple as accessing your control panel. Now, DigitalOcean is built for developers, and it's used by over 400,000 of them, including me. You can deploy and configure your droplets via a streamlined control panel or a simple API. You get to choose your OS: Ubuntu, CentOS, Debian, Fedora, CoreOS, and FreeBSD. A one-click install allows you to quickly deploy apps like Django, Docker, Drupal, LAMP, GitLab, MediaWiki, Node.js, WordPress, Ghost, Magento, OwnCloud, Ruby on Rails, and more. Well, all servers are built on hex-core machines, then they have dedicated ECC memory and RAID SSD storage, and they can have up to 20 CPUs, 64 gigabytes of memory, and 640 gigabytes of SSD space. They're highly scalable. That means that you could start small. Say you want to do a beta just to get some real-world metrics on traffic, and then push it up to worldwide deployment, all with just a flick of a switch. You can also get auto backups and snapshots, so they'll take care of that scut work for you. You get to focus on creating the best service or app possible. They give you full-featured DNS management with web console access through HTML5 plus SSH, SFTP, and KVM VNC for your virtual desktops. And if you want, they will even give you dedicated IP addresses. Now, you get gigabit speeds, world-class reliability, and 99% uptime. They've also got an extremely active community, which I find is a great indicator of how strong a company is. If the customers of a company are willing to come back and share their experiences, share their solutions, then you know that you can trust them. That's exactly what DigitalOcean has. It's so easy to get started that you could be up and running with your own cloud server in as little as 55 seconds. Oh, folks, I can't say enough how easy it is to use DigitalOcean, but we're going to give you one more incentive to do it, and that is, well, it's going to be free for you. DigitalOcean has incredibly affordable and straightforward pricing, with their services starting at just $5 per month, and they also have hourly pricing available. But if you get started today and deploy your SSD cloud server, you can do it for free. Visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code C101 for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do for you. That's DigitalOcean.com. And once you sign up, enter the code C101 in the billing section for a $10 credit. And we thank DigitalOcean for their support of Coding 101. Lou, where do you think we should go from here? Because, I mean, most Arduino projects are like this. Some sort of external stimuli, some sort of internal processing, and then some sort of push out to a data display device. Where should we go next?
You could always add. You could add some redundancy to the system. Maybe use a laser rangefinder or something like that. Yeah. Or you could always again more feedback. Maybe sound.
Oh yeah, actually that's
audible.
Actually, that now you've just decided what I'm going to make for my parents. Or maybe how about a rumbler?
Yeah. They have those on Cadillacs, actually. As you start to kind of move into the next lane, like your seat will start to rumble.
Yeah. Actually, there is a Bluetooth module for this, so I wonder if I could make like a little app for my parents. They'll start buzzing their phone if they're getting too close to the garage door. Something else I should mention is people have said how inaccurate ultrasonic sensors can be. That is completely true. You're not going to, I mean, they're close, but they're not going to give you high definition like a LiDAR. We actually covered that on Know-How. A little spinning device on top of, say, a quadcopter that gives you a real world, very, very accurate depiction of the world around you. But the advantage of this over LiDAR is a LiDAR sensor could cost you $300 to $1,000. Right. These could cost you 99 cents. So you can afford to put a lot of these around an object, and it will get you within 90% of the accuracy of a LiDAR device within, say, 5 feet. So that's really the limitation of this technology. You could get better sensors, and they would work exactly the same way. The same logic tree that we just created for the ultrasonic sensor, you could use with a LiDAR sensor. You just change the range. Lou, that's actually the case for a lot of this logic, right? I mean, you just scale it up and down depending on the resolution of your sensors.
That's right. The more redundancy you have in a system with more feedback, you could do all the math to determine how accurate it is, and then you can make decisions based off of that. So it's always good to have more backup redundancy systems in these type of small circuits, especially depending on how accurate or how precise they are. But yeah, the more precise, the less you have to have. But again, you always have to have backup. So if you're going to buy a LiDAR, it's going to probably be 2 of them, right? So it's going to be $600. So I think that's where you want to make sure you have some way of, maybe you have several other devices in that system to kind of back it up.
Yeah, absolutely. Well, Lou, I want to thank you again for being here, especially with a super fresh baby. I mean, wait, is your child 24 hours old yet?
Maybe. Yeah. He actually is on his way home right now, so we'll see him in about 10 minutes.
So we should be able to see your child in the next episode. Well, maybe. I don't know if you actually want to bring him into super internet stardom yet, but you can do that. I will also mention that we have some fun announcements coming in the following episode of Coding 101, which we will be taping tomorrow. I don't normally tell people that we're going to be taping, but we're taping it tomorrow because, well, Lou is a new dad, and I thought that maybe he should spend more of his holiday with his child than worrying about Coding 101. But we've got some fun stuff coming up with Lou Maresca. Lou, could you tell the folks where they can find you when all these announcements come out and they want to rush over to you and ask for your advice on things? Where should they go?
You can always find me on Twitter at LouMM, and of course also on Google Plus in the Google Plus community. There is El Maresca over there. And of course, all my work at Microsoft is found at crm.dynamics.com. Absolutely.
And again, Lou, thank you so very much. Don't forget that we do this show on Mondays at 2:30 p.m. Pacific time, or at least that's where you'll be able to find it. And we have our show notes at twit.tv/code. This exact code, this exact module, this zip file will be available for download. So if you wanted to start playing with an Arduino today, if you've got one in a back lab somewhere that someone gave to you that's been gathering dust because you didn't know what to do with it, if you can find an ultrasonic sensor, and if you can find a string of WS2812 LEDs, you could have this very project up and running today in a matter of minutes. Again, just go to twit.tv/code and click on the download button. Finally, I want to thank everyone who makes this show possible. Of course, to Lisa and Leo for letting us do Coding 101. To Lou Maresca, who is, well, he is the best of possible co-hosts for a programming show. Such dedication to be coming in right after his baby was born. And to my TD of the day, Mr. Jason Howell. Jason, I don't normally have you as my TD, but when I do, I find you to be the most exciting TD in the world. Could you tell folks where they can find you on the Twit TV network?
Exciting because while you're doing your show, I'm behind the desk juggling stuff.
Juggling. We love the juggling.
You can find me, I do all about Android and Android stuff on the network, twit.tv/AAA or twit.tv/arena. In fact, what do I have here?
Oh, no.
I have 3 boxes.
Boxes of boxes.
Of Pixel C craziness.
Oh, my goodness.
So I'm sure we're going to show this off on tomorrow night's episode of All About Android.
You know, I saw Leo's on the screensavers on the weekend, and that is a sweet machine.
I'm excited. I'm excited to dig in. I have some reservations about Android as a productivity platform, but we'll see if this will convince me otherwise.
Indeed. One last note: if you want to see any of these projects on the hardware side, remember we will do them as know-how projects. We've done this before. When Smitty came in and showed us his clock, we did the software on this side, we did the hardware on that side. We're going to do the same thing, both for the lighting project and for the ultrasonic sensor project. So don't forget to go to twit.tv/KH. You'll find it there in the new year. Until next time, I'm Father Robert Ballecer, the digital Jesuit. And Lou, how do we end the show?
End of line.